Dear students, in this video we are going to learn about the concept of file system implementation. A file is a collection of related information. The file system resides in the secondary storage and it provides efficient and convenient access to the disk by allowing data to be stored, located and retrieved. So file system resides in the secondary storage. It provides efficient and convenient access to the disk by allowing the data to be stored, located and retrieved. File system implementation in an operating system refers to how the file system manages the storage and retrieval of data on physical storage devices such as hard drive, solid state drive or flash drive. So they are nothing but hard drive and solid state drive are nothing but secondary storage devices. Flash drive is nothing but the pen drive. File system implementation in an operating system refers how the file system manages the storage and retrieval of data on the physical storage. So how the files are stored, how they are to be retrieved. All these things are managed by the file system management. File system implementation. File system components. The file system implementation includes several components like file system structure, file allocation, and data retrieval, security and permission, recovery and fault tolerance. File system structure. The file system structure refers to how the files and directories are organized and stored on the physical storage. This includes the layout of the file system's data structures such as directory structure, file allocation table, inode table, etc. The file system structure includes how the files and directories are organized and stored on the physical storage device. That means it deals with the data structures for files and directories. File allocation. The file allocation mechanism determines how the files are allocated on the storage device. There are various allocation techniques are there, that is contiguous allocation, linked file allocation, indexed allocation, like that. Various types of file allocation schemes are there. Which scheme is to be used, they are dealt by the file allocation mechanism. Then data retrieval. The file system implementation determines how the data is read from and how it is written to the physical storage device. So this includes how the files are buffered and how the file directories are cached into the main memory to optimize the file I/O performance. Security and permissions. The file system implementation includes features like managing the file security and permissions. Because if we do not maintain the file security and permissions, then unauthorized users may access the files. So therefore, in order to avoid this unauthorized access of files, so access control list is maintained for each and every file, that includes file permissions and ownership of the files. Recovery and fault tolerance. The file system also deals with the recovering of the files from the system failures and maintaining the data integrity. That means when a file is updated, it must be recorded in the secondary storage for the maintenance of the data integrity. So this includes techniques such as journalism and file system snapshots. This includes techniques such as journaling and file system snapshots. Coming to file system structure. File system implements the file structures. File system resides on the secondary storage. File system structure is organized into various layers. The file structure concept. It is a logical storage unit and it is a collection of related information. The file structure is a logical unit and it is collection of related information. This information is organized into various layers. So layered file system structure. So it contains application programs on the top layer. So that provide what are all the files that are need to be accessed, what operations are to be performed on the files. All those things are given with the help of application programs. Then logical file system, file organization module, basic file system, I/O control and devices layer is maintained. Coming to the logical file system. The logical file system manages metadata about the file system structure in the form of a file control block. The file control block contains information about the files. So let us see what is a file control block. When a file operation is required, the operating system uses this file control block associated with each file located to files data on the storage device, and it will check what are all the permissions to perform the requested operation. So file control block is having all the file related information like file permissions, date of creation of the file, and when the file is last accessed and when the file is last updated, and who is the owner of the file. So what is the group ID to which the file belongs to, and the access control list. That means what are the permissions for the user, groups and others of the files. Then what is the size of the file. Next, coming to the file data blocks or pointers to the file data blocks. That means it will also hold the address of the data block where it is stored in the disk. So file is stored in a collection of data blocks. These are in the disk. So file data blocks will also have a pointer to the data blocks in the secondary storage. Coming to file organization module. File organization module maintains information about files and translates logical block address into physical block address. So file organization module converts the logical block address into physical block address. Then basic file system issues generic commands like what is the operation to be performed, whether it is read, write to or open, something like that, and what is the drive number, and what is the cylinder number, track number and sector number. This is how a generic command is issued to the device driver for accessing the file from the corresponding location. Then device drivers, it is the lowest level of I/O control with interrupt handlers to transfer the data between the memory and disk. So device drivers is like an interface between the operating system and the storage. So when there is a request for a specific file block, then these device drivers will get the block from the disk and transfer it into the memory. And in the same way, from memory to disk also, these device drivers will transfer the file blocks. File control block is already discussed. Then file system maintains, in addition to file control block, it also maintains a directory structure, per process open file table, system wide open file table in order to perform file related operations in the operating system. So directory structure, as we know that it will maintain the list of files and directories stored in that particular directory. Part of the directory structure is stored in the main memory. Then per process open file table is used to store the list of files opened by a process and their corresponding file pointer locations, and a reference to the system-wide open file table is also stored in the per process open file table. System-wide open file table is going to store the list of files opened by all the processes in the system. That is maintained by the system-wide open file table. So the difference between per process open file table and system-wide open file table is, per process open file table, it is specific to a process. What are all the files are opened by the process. System-wide open file table is for the entire system. So all the processes, what are their files opened. So all that information is stored in the system-wide open file table. All these four components are, all these four entities are required for performing file related operations like opening a file, reading the contents of the file, closing the file, like that. So now let us see when a file is created. So what operations are carried out in the system. To create a new file, an application program calls the logical file system. The logical file system knows the format of the directory structure. To create a new file, it allocates a new file control block for that file. Then the system reads the appropriate directory into the memory and updates it with the new file name and its corresponding FCB and write it back to the disk. An in-memory directory structure cache holds the directory information of recently accessed directories. System-wide open file table contains copy of the FCPs of each open file as well as other information. So these are all the actions that are happened inside the system when a file is created newly. So initially when a file is created, it makes a call to the logical file system. The logical system file knows what is the format of the directory structure. Then it creates a new file and allocates a new FCB. Then the system reads the appropriate directory where this file is to be stored into the memory, and that directory is updated with the new file name and its corresponding FDP and write it back into the disk. Then the system also maintains in-memory directory structure cache that holds the recently accessed directory information. And a system-wide open file table holds copy of the FCB of each file as well as the other file related information for all the processes in the system. In-memory file system structure. Let us look up when a file is opened, what is the necessary operations that are carried out in the system. Assume that a process is opening a file. When a process is newly opened, the operating system, file system, first refers the directory structure which is already in the main memory to look out for the status of the file, whether it is already opened or not opened. Then if it is not opened, the corresponding directory structure of that particular file is identified and it is brought into the main memory. So once it is brought into the main memory, so already the directory structure will hold the pointer to the corresponding file control block of that particular file. So in this way, when a file is opened newly, the corresponding directory structure is loaded into the kernel memory afresh. So reading the file, the open system call first searches the system-wide open file table to see if the file is already in use by another process. If it is in use by another process, a per process open file table entry is created pointing to the existing system-wide open file table. So this algorithm can save substantial overhead in again opening the file and bringing the contents of the file into the main memory. When the system wants to read the contents of the file, first it will check the entry in the per process open file table whether the file is already opened or not. If it is not open, then it will check the system-wide open file table to verify whether the file is in use by any other system, any other process. So in that case, if the file is already in the system-wide open file table, then the per process open file table will make an entry pointing to the system-wide open file table corresponding to that particular file. System-wide open file table generally will be having the information of the file control block, which in turn will be having the address of the data blocks where the file is actually stored. If the file is not already open, the directory structure is searched for the given file name. Then parts of the directory structure are usually cached in memory to speed directory related operations. So that means if the file is not opened, then the corresponding directory structure is loaded into the main memory. Suppose if the file is found, the FCB is copied into the system-wide open file table in memory. This table not only stores the FCB but also tracks the number of processes that have the file open. Next, an entry is made in the per process open file table with a pointer to the entry in the system-wide open file table and some other fields. The virtual file system. Virtual file system provides an object-oriented way of implementing file system. It allows same interface for different types of file systems. Assume that we have different disks, disk 1, disk 2 like that, and some other disk connected over an. So disk 1 is having some logical file system of type 1, disk 2 is having a logical file system of type 2. So we can consider the VFS will provide the same uniform interface to all the file systems irrespective of the type of the file system followed. So like it will give a common APIs like open, read, write and memory map like that. These type of common APIs will be provided by this virtual file system interface to provide a uniform access to different file systems. How the directory structure is implemented. Directory structure is implemented by using two different methods. One is linear list, another one is the hash table implementation. So what is linear list of directory implementation means? Directory structure maintains a linear list of all the files and its corresponding pointers to the data blocks. So like this, it will maintain the collection of nodes. Okay, so each node contains information about the file and its related block numbers. For example, file 1 and its corresponding blocks, they are all maintained in this node. Similarly, file 2 and its corresponding block numbers. File 2 and its corresponding block numbers are maintained in the next node. Like that, all the files maintained in the directory are maintained in the form of a linear list of file names. It is a simple program for implementation, but it is a time consuming process to search for a specific file. For example, if this directory structure contains some 100 files, then it will be having a list of 100 nodes, linked list of linear list of 100 nodes. Suppose if we want to find the information about one file whose number is 99, then we need to start from the beginning of this linear list and we will access the each entry and we go up to the 99th node. Then we find the block numbers of that particular file and then access the contents from those blocks. So in this way, it is a linear access. It is a time consuming. As the length of the list increases, it takes more time to search. So therefore, we go for another method of directory implementation, that is hash table implementation. It is also a type of data structure, but it provides a direct access because it maintains a hash table. That means when a file is to be stored, then a hash value of that particular file is computed and the details about that file, that is the block numbers corresponding to that file, is stored in that hash table entry and the block numbers are stored in the hash table entry. So therefore, it decreases the search time because it provides direct access to the table. But when there are more number of files are having same common name, then it will be hashed to the same address or location in the to the same location. Therefore, this leads to collisions. In that case, we need to follow some collision resolving techniques to map the collided locations to a new location. Next, file allocation methods. File allocation methods deals with how efficiently the data blocks are allocated to the files on the disk. So allocation of the blocks to the files. So disk is a collection of blocks. A file occupies one or more number of blocks in the disk depending on its size. So when a file is occupying more than one block in the disk, how and where these blocks are stored in the disk needs to be maintained by the file system. So how the file system will maintain the block addresses of each and every file, that is dealt by the file allocation methods. So there are three different types of allocation methods followed by the file system. One is contiguous file allocation, linked file allocation, indexed file allocation. Coming to the contiguous allocation, each file occupies set of contiguous blocks. It performs best in most of the cases, and it is also simple because we need to store only the starting address of the file block and the length that refers to the number of blocks required. So only these two information we need to maintain for each file, that is starting location block number and the number of blocks, because they are stored in the contiguous locations. So the main problem with this approach is if the blocks are not contiguous and if they are spread in the different locations of the secondary storage, then finding the contiguous locations for storing a big file will be a problem that leads to external fragmentation. In that case, we need to go for compaction process in order to bring all the free blocks to one side of the disk. So let us see an example how this contiguous allocation stores the file in various blocks in the disk. So a directory table will maintain what are all the file names and its starting location of the block and the number of blocks it is holding. So count is a file which is stored from the starting block 0 and the number of blocks occupied by this count file is 2. So that means these two are the blocks occupied by the file count. Next, tr is another file whose starting block is 14 and it is occupying 3 contiguous blocks. So that means 14, 15, 16 are the blocks occupied by tr. Similarly, list is another file whose starting block is 28 and it is occupying 4 blocks. So 28, 29, 30, 31. These are the 4 blocks occupied by the list. So in this way, the entries are maintained by the directory structure to hold the what are all the blocks occupied by the file. So when we want to access a particular block and the corresponding address within the block, then what we need to do is we need to find the starting address of the block plus the displacement within the block. So that will be providing the block having a specific address. So Q plus starting address will give you the block to be accessed address and displacement into the block will be obtained by R. Suppose Q is the block number. Consider 1 is the block number. So block number 1, the starting address of that particular file is given. The starting address of the file is given, and within that block, what is the instruction number? That is R. When we add all the 3 components, we will get the address of the instruction in any specific block within the disk. When we want to access a block, when we want to access a specific instruction within a block, then we can access that instruction by using 3 components. One is the block number and its starting address of the file plus displacement within the block. All these 3 components are essential to access a specific instruction within the block. So that can be obtained. For example, the block number Q is 2. So 2 plus the starting address of the file. So that is given plus block number within the block instruction number. That is obtained by R. So all these 3 components, if you add, we will get the address of the instruction in any specific block for that particular file. So next one is a linked allocation method. In linked allocation method, each file maintains a linked list of blocks. The end of the file is indicated by using a null pointer in the last block. So the advantage of this method is no need of having the contiguous blocks for storing the file. So therefore, we don't get any external fragmentation. Let us see one example. A file is stored from the block number 9. So zip is a file which is stored from block number 9. So 9 is the block number where the file is stored, and it will maintain the address to the next block, address of the next block. The address of the next block is 16. So therefore 9 will be, the last entry in 9 will be holding the address of 16. The 16 will hold the part of the file, and the last entry in the 16 will hold the address of the next block. Again this block will hold the part of the file, and hold the last entry hold the address of the next file, next block. So from 1 it will go to the block number 10. From block number 10 it is having a pointer to 25. So 25 is the last block for that file. So the last entry in 25 will be having -1, that indicates the end of the block. So where the file ends. So the directory structure also maintain what is the starting address of the file and also ending address of the block for that particular file. This is linked allocation method for files. So since there is no external fragmentation, we don't want to go for any compaction, but we need to maintain a free space memory management in order to keep track of which blocks are occupied and which blocks are free, in order to allocate the blocks when there is a need for file storage. So then this can be improved. The efficiency of this method can be improved by using a technique called clustering blocks. This clustering blocks groups the free blocks. Locating a block can take many IOs and disk seeks. That is the disadvantage of this particular linked allocation of file. So let us see how the file allocation table maintains the address of the files and its corresponding pointers to the blocks. So name is the name of the file. So test is the file whose starting block is 217. 217 is having the address of the next block 339. So 618 is having data along with the address of the next block. So 339 is having the next block. So 339 may be the last block of the file. It will have -1 at the end of the file content. Another method of file allocation is indexed file allocation. In this, each file will be having an index table having the list of pointers to the data blocks. So therefore, see this one example, Jeep is a file name. It will have an index block stored in the block number 19. This block number 19 will be having the list of the blocks where the file is stored. Okay, so 9, 16, 1, 10, 25. These are all the 5 blocks used by the file Jeep in order to store its information. And one entry, that is one block is entirely reserved for storing the information about the blocks which are occupied by the file. And the remaining entries in this block will be made -1. That indicates that the part of this block is made vacant. So this leads to internal fragmentation because the file does not require the entire block to store the addresses of the block numbers where the file is stored. So that is the disadvantage with this indexed allocation. So each file will be having its own index block that holds the pointers to the data blocks. So in order to, sometimes the index table will be bigger in size. So the entries in this index table is accessed in the sequential order. So therefore, if we require any specific block, so we need to traverse the index table in the linear order. So therefore, it consumes more time. So in order to avoid this consumption of time, we can maintain an outer index table to the inner index table. So in that way we can reduce the time taken for accessing a specific index of the block. So whether the which blocks are free, which blocks are empty in this disk, maintaining free space management deals with the maintenance of the which blocks are free, which blocks are occupied in the disk. The techniques followed by the free space management is bit vector, linked space management, grouping, counting techniques. So these are the 4 techniques followed by free space management. Bit vector. Suppose if the disk is having n number of blocks, for example disk is having 0 to n minus 1 number of blocks. So that means total n blocks are there. Which blocks are free, which blocks are empty, which blocks are free and which blocks are occupied. They are maintained by using a bit vector. So what is mean by bit vector? It is nothing but an array of n bits. Each bit corresponds to one block. So bit 0 is corresponding to block 0, bit 1 corresponding to block 1, bit 2 corresponds to block 2, like that. If any of the block is vacant, free, then it is indicated with symbol 1, entry 1. Entry 1 indicates that the corresponding block is free. If any block is occupied, then the corresponding entry is made 0. 0 indicates that the corresponding block in the disk is occupied. So in that way, by seeing the contents of this bit vector, it will give the information about what are the blocks free, what are all the blocks occupied. So by seeing this bit vector, if you want to have a contiguous data blocks of size 3, then you can traverse this bit vector and you can easily find out where these contiguous 3 blocks are available. So you can select those blocks and allocate the blocks to the file. In that way you can find out the contiguous blocks from the bit vector easily. Coming to the linked free space list on the disk. So it will maintain the list of free disks in the It maintains the list of free blocks in the disk. The first free block address is held by the head of the list. This list in turn holds the address of the next block. This block will hold the address of the next block. This block will hold the address of the next free block. Like that it will maintain the, anyway the blocks are free, it is going to hold the address of the next free block in the entire in the disk. So the last disk will be having, the last block will be having the address -1. That indicates that this is the last vacant block in the disk. So therefore in this case we don't need to have to maintain a separate bit vector or separate memory to hold the list of free blocks. So therefore there is no wastage of space. But in order to find out a contiguous vacant blocks, we do not have any methodology to find the contiguous free blocks. Just we need to traverse through this linked list in order to find out the vacant blocks, whether they are contiguous or not contiguous, by traversing through the entire list. So therefore we need to find the vacant blocks only by traversing through the linked list of these free blocks headed by the head pointer. Grouping is another method for maintaining the free space management in the disk. It will maintain a linked list to store the addresses of the next n-1 free blocks in the first free block, and it also maintains a pointer to the next free block that contains the free block pointers. So like You see here, block number 2 will be having the addresses of, anyway the block number 2 is free. Instead of keeping free, it will maintain the addresses of the next free blocks, -3, -4, 5, like that. It will maintain the addresses of the next blocks 3, 4, 5, and also the last address is the block number holding the addresses of the next available free blocks. So likewise, these are the contents of the block number 2. Block number 2 contains 3, 4, 5. They are the free blocks immediately following 2. And block number 8, that holds the address of the next free blocks following 8. So contents of the block number 8 in grouping method is 8 holds the addresses of free blocks 9, 10, 11, 12, 13 and 17. 17 is the last block in block number 8. So coming to 17 will be having the address 18 and 25. So this is the grouping method for holding the addresses of the free blocks. Then coming to the counting method. Counting method, instead of maintaining the free block addresses, it will maintain the count of the free blocks following the free block. So coming to the counting method. In counting method, block number 2 will be having 2 entries. How many free blocks are following 2? And the address of the next free block. So 3, 4, 5. There are 3 blocks are following 2. And 8 is the next free block that is holding the next count. That is the meaning of these 2 entries. Then coming to 8, block number 8. Similarly, 3 also will hold. 3 will be holding the information like it is for having 2 following free blocks, and the address of the next block is 8. Okay, then 8 will be having the details like how many free blocks are following? 1, 2, 3, 4, 5. 5 is the number of free blocks following 8. Then address of the next block having the pointers is 17. 5, 17. This is about the counting method of storing the free blocks in the disk. In this way, we maintain the free space management in the disk by using 4 methods: bit vector, linked list method, and grouping method, counting method. Thank you for watching this video.